Okay, so today we wanted to talk about section 3.4, zeros of polynomial functions. So we have very powerful theorems here. Okay, so the first one, we want to talk about the rational zero theorem. So let fx be defined as integer. So has integer coefficients. And p over q is the rational zero of f. Then p is a factor of the constant term a0, q is the factor of the leading coefficient an. Okay, so in order to use this theorem, what do we need about the coefficient of this polynomial? It has to be what? Integer. So this, what does this mean? The possible rational zeros is p over q, means factors of the a0 constant term over the factors of an. Okay, so this is the simplified version. Okay, so now let's look at the example. X cubed minus 17x squared plus 8x plus 8. Find the rational zeros here. Okay, so what, in order to use the theorem, what is the a0? Is the constant term, is 8. What is the leading coefficient? Which is the coefficient of x cubed, yeah? So equal to 1. So what are the factors of a0? 8. What could you make a 8? 1, 8. Or what? 2, 4. You with me? But do not forget what? Plus or minus. This is very important. Okay, how could you find the factors? Just, do it like 1, 8, 2, 4, or, whatever it multiply, give you this number. Okay, at the q, factors of 1 is only 1, so do not forget what? Plus or minus. So what are the possible zeros? Possible rational zeros is p over q equal to plus or minus 1? Because the denominator is 1, so it does not matter, plus or minus. So you can keep all these things, yeah? Okay, so now we wanted to see which one is the right one. That is painful part, okay? So then we have to try every one. So x equal to negative 1. Okay, use sensitive division. How could we know that it's a 0? Yeah, so you check the what? Remainder. If here the remainder is not equal to 0, what happened? Then it's not a 0. Okay, so you have to repeat the sensitive division. Negative 1 times 1, negative 1. 1. Here is multiplication. Here is what? Addition. Repeat again. Okay, so x equal to 1 again. So I will do 1 with you. Maybe 1, negative 17, 8, 8. Okay, so for the first one, what will you do? You put it back, yeah? 1 here, yeah? So what do you multiply? And then you add here, negative 16. Negative 16 times 1, you have what? Negative 16. You add negative 8. 1 times negative 8, you have negative 8. You add here, what happens here? You add here, what do you have? 0. Wow, so the remainder is 0. Okay, the remainder is 0. What should we do now? Yeah, we found one, yeah? Okay, so do we need to try the others? No. Okay, so do you remember? So what do we have? Is x cubed minus 17x squared plus 8x plus 8, yeah? You divide by what? X minus c. What is your c here? 1. So that will be your what? What is the quotient here? The first term is always what? 1 power down. So it's x squared minus 16x what? Minus 8. You with me? Minus 8. Do we have a remainder? 0, so it's gone. So what does this tells you? X cubed minus 17x squared minus 8x plus 8 equal to what? X squared minus 16x minus 8 times x minus 1 equal to what? 0. Okay, so what does this mean? You let each part equal to 0, x minus 1 equal to 0, or x squared minus 16x minus 8 equal to what? 0, so x equal to what? 1. Okay, so you can try to solve this. How could we solve this? Could we factor? No. So then what should we do? Quadratic what? Formula. So I will do it quickly for you. It will be 16 plus or minus square root of 256 plus 32 is 288. So I simplify 16 plus or minus 4 is 2 squared to 71. Okay, so it will be 8 plus or minus square root to 71. Are they rational? No. So the only rational zeros, because this you have radicals, it's not a rational number. So the only rational zero is what? X equal to 1. Okay, so in the homework, most likely they will ask you all the possible one or find one rational zero. Okay, and if in the exam, typically, if we want to find all the rational zeros, this means the other ones are easy to find. It will not be this complicated. Okay, but it's very good to understand all the techniques. Okay. So the next theorem is called what? Fundamental theorems of algebra. So if fx is a polynomial of degree n, where n bigger than or equal to 1, then fx equals 0 has at least one complex root. It means always has a solution. It might be complex. Okay, so there are some very important properties. So if a polynomial equation with degree n, if counting multiple roots separately, the equation should have what? N roots. So this means degree 2, 2 roots, degree 3, 3 roots, degree 4, 4 roots. Okay, and continue. And if this is a very powerful one, if a plus b plus bi is a root, then the conjugate is a minus bi is also a root. So the complex root always come as a pair. Okay, so these are very good, important, properties. And the one more is called what? Linear factorization theorem. So let fx equal to this, and fx can be factored. X minus c1, x minus c2, okay? And where c1, c2, cn are what? The roots, the complex roots of fx. Okay, so let's do one question like this. Okay, example, solution. So we found to find the nth degree polynomial satisfy n equal to 3. 2 and 2i are zeros, f negative 1 equal to 15. So n equal to 3. So this means what? Degree 3. Yeah, so fx. So which theorem should we use to write this polynomial? And we know some zeros means roots, yeah? If I were you, I would use this one. The linear factorization theorem. So an times x minus c1, x minus c2, and x minus how many? N equal to what? 3, yeah? So we only have 3, x minus 3. And an should be what? A3 here. Yeah? Okay? Okay, so what do we have here? What are the information do we know? So A3 we do not know. Do we know C1? C1 is 1 with the root, yeah, 2. C2, that's 2i. Do we know C3? do not know from the question, yeah? That's too sad. Could we find it? Yeah, do you remember one of the property? If a plus bi is a root, a minus bi is also a root. So if 2i is a root, what is definitely another root? Negative 2i is also another root. Okay, so it's x minus negative 2i become what? Plus 2i. So your fx equal to this. Could we simplify this a little bit? It's a cube x minus 2, x minus 2i, x plus 2i, what do you have? X squared, you FOIL this part here. Minus 2ix plus 2ix and minus what? 4i guys square. Okay, do not forget. So what do we have? A cube x minus 2 x squared. What is I squared again? Negative 1. So minus 4 times negative 1 is what? Plus 4. Okay, for the moment I will not FOIL this. I will first find a first and then multiply. Okay, so what will be f of negative 1 is a cube negative 1 minus 2 times negative 1 squared plus 4. So what does this thing equal to? 15. So we have a cube. What do we have here? Negative 1 minus 2 is what? Negative 3. Okay, not the negative 1 again, so it's minus negative 3. Negative 1 squared is what? 1. 1 plus 4 is what? 5. So it's 15. Negative 3, so it's negative 15. A3 equal to what? 15. What will be a cube? Divide and not add, so it's negative 1. So what do we have here? Fx is negative 1, negative sign, times x minus 2 times x squared plus 4. Then what do we have here? We can FOIL it again. X cubed minus 2x squared plus what? 4x minus 8. Then you distribute the negative sign. It's negative x cubed plus 2x squared minus 4x plus 8. Okay, so this is your polynomial. Okay, so the key here is first step, you use n equal to 3, determine how many words do you stop, how many factors do you have here. Minus 3, minus c1, minus c2, minus c3, and you have a3. And then you substitute seeds for all these, roots. Do not forget, complex roots come as a pair. Okay. So then the next rule we wanted to talk about is called discuss rule of signs. So let fx be this. The number of positive. Oh, I have two positive. Yeah. The number of positive zeros of fx is the same as the number of. Okay. Sorry. The number of sign changes. Okay, the number of sign changes of fx, or less than the number of sign changes by a positive even number. Okay, so the number of negative zeros. Okay, so I want to save some writing. Is what fx. Okay, so the fx. Of the fx is the same as the number of sign changes, not of fx anymore, is of the what? F negative x. Okay, so it's of f of negative x, okay, or less than the number of sign changes by a positive even integer. Okay, so what do we wanted to do for discuss rule? We wanted to see how many positive zeros do we have, how many negative zeros. So positive zeros is the sign changes of what? Okay, so we wanted to see the rule. So positive zeros are related with what? Sign changes of fx. So the negative zeros, oh my god, the negative zeros, so number of negative zeros are related with sign changes of f negative x. Okay, so these are the rule here. Okay, so the positive zeros are related with sign changes of what? Fx. The negative zeros are related with sign changes of f negative x. Okay, so in order to understand this easily, so we wanted to look at the example. So the possible number of positive zeros. Okay, so we wanted to see fx, yeah, so fx equal to negative 3x cubed plus 2x squared minus 9x plus 5. Okay, so how many sign changes? Here we only look at what? The leading coefficient. Here is negative, here is positive. Okay, one sign changes. Positive to negative, another sign changes. Negative to what? Positive, another sign changes. So how many sign changes here? 3 sign changes. So how many number of positive zeros is 3? Yeah, or what? Because we also wanted what? Less than the number of sign changes by a positive what? Even integer. This means what? What will be the even integers? 2, 4, 6, 8. Yeah. So what will you do? 3 minus 2 is what? 1. Are you with me? Yeah. Could we minus another 2? Not anymore, because it's not enough. Yeah. So if you have 7 sign changes, so what are the possibles? It can be 7, or minus 2, 5, or 5 you can continue to minus 2, 3, or 1. Are you with me? Okay, so this is the rule here. Okay, so it's 3 or 1. So for the number of negative zeros, so what do we need to do? We have to find f of negative x. So negative 3 negative x cubed 2 negative x squared minus 9 negative x plus 5. So what do we have here? Negative x cubed, do you have the negative sign, or negative sign disappeared? You do have, because 3 of them you do have the negative sign. Yeah, so it will be negative 3 times negative x cubed. Negative sign disappears for square, so you plus 9x plus 5. So negative 3x cubed plus 2x squared plus 9x plus 5. So what happened here? Positive, 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 positive. What happened? Do you have any sign changes? No sign changes. So how many number of negative zeros? 0. Because you do not have any negative zeros. Okay? So what does this tell you? What does this tell you? So how many zeros, total number of zeros you have? 3, yeah? So because this is a polynomial of degree 3. And how many negative zeros do we have? 0. Then all the zeros must be what? Positive. So how many positive zeros could we have? 3. is not y anymore because we do not have negative zeros. Okay, so for the number of positive zeros is 3, and the number of negative zeros is 0. 1 does not work because we do not have any negative zeros. Okay, that's for this one, this section.